Pythagoras' theorem can be visualized using areas. In other words, if we add the blue and the orange areas, we will obtain the green area. 3 squared plus 4 squared equals 5 squared. In any right angle triangle, if we draw squares emerging from the 3 sides, we'll find out that the sum of the smaller squares equals the big square. Let's see an application of Pythagoras' theorem. A ladder has legs 10 meters long. The legs are 1.5 meters apart at the base. How tall does the ladder reach? We use Pythagoras with hypotenuse 10 and short side 0.75. That's right, Pythagoras only works in right angle triangles. The ladder reaches 9.97 meters high. Here we have the simplest triplet. The circle touches the sides of the triangle 3, 4, 5. Can you estimate the size of the radius? Stop the video here and make a guess. The circle with radius r divides the sides of the triangle like this. The interesting thing, and what I want you to notice, is that if we draw a line from the center of this circle to the top vertex, this will divide the top quadrilateral into 2 equal triangles. That's right, both are right angle triangles with 2 equal lengths. So the remaining length must be the same, 3 minus r and 4 minus r. The 5 can be divided into these 2, and collecting like terms and solving for r, we obtain the radius of our smallest triplet. R equals 1. Let's say that we want to calculate the distance between these 2 points. The horizontal distance, 3, and the vertical distance, 4, make a 90-degree angle. So we can use Pythagoras to find the hypotenuse, c equals 5. This approach works even if the points are on different quadrants. For example, to calculate the distance between the point -2, 4 and the point 5, -2, we find the short sides, 7 and 6, and the square root of 85 is approximately 9.22 units. In general, to calculate the distance, we find the short sides and use Pythagoras. The 2 short sides are found using the difference between the x coordinates and the difference between the y coordinates. The distance is the square root of the sum of the squares. Let's use the formula to calculate the distance between the points. The square root of 5 minus 2 square plus 1 minus 4 square. This is approximately 4.24 units. The square root of -5 minus -2 square plus -a minus 6 square. This is approximately 14.3 units. Maria wants to decorate the room using Itsy Bitsy Spider. She needs to connect the top right corner of the room with the bottom left corner. How much string does she need? Well, we are going to use Pythagoras once to find the distance x, and then again to find the distance across the room d. Or look at this. We could do it in one go. Pythagoras in 3D. We can generalize the formula to include a third dimension. For example, the distance in 3D between points 3, 4, 5 and 1, 1, 1 is found calculating the square root of the sum of the squares of the 3 short sides. The square root of 29 is approximately 5.39. We are going to use Pythagoras in 3D to calculate the volume of this square base pyramid. For that, we need the height and substitute this into the formula. Volume equals a third of base times the height. The inside looks like this, and the height falls in the middle of the square. The height makes 90 degrees with the base, so we can use Pythagoras with hypotenuse 6 meters and short side equals to half of the diagonal of the square. The diagonal is the square root of the sum of the squares of the 2 sides. So now you have it, and use Pythagoras in reverse to calculate the height as one of the short sides. H is the square root of 6 squared minus 5.66 squared. H is 2 meters. Replacing H with 2, the volume is 42.7 meter cube. But how about the surface area? This is the net of a pyramid, and we can use Pythagoras to calculate the height of the face. This equals 4.47 meters. The area of one triangular face is a half of the base, 8, times the height, 4.47. Adding the 4 triangles plus the area of the square base leads to 135.6, the surface area of our pyramid. If you are using this as a calculus refresher, I made it easy to navigate. Click the link below to find all 15 lessons hosted individually, each with its own corresponding PDF guide. We are going to use the trigonometric ratios sine, cosine, and tangent. The sine of A is the ratio between the opposite side and the hypotenuse, 3/5. The cosine of A is the ratio between the adjacent side and the hypotenuse, 4/5. The tangent of A is the ratio between the opposite side and the adjacent side, 3/4. Well, these two triangles are similar triangles, meaning that the sides are in the same proportion. Similar triangles have same exact angles, and your calculator knows that. Your calculator has this information stored. So take note of these ratios and let's use them. For example, we can use the ratio sine of 30 as the opposite 6 over the hypotenuse x. We write this as an equation and we solve for x. Another example, we can use the ratio cosine of 40 as the adjacent 7.5 over the hypotenuse. We write this as an equation and we solve for y. This is an example where the two sides involved are the opposite and the adjacent. So we use tangent. We write tangent of 52 equals z over 162 and we solve for z. Z equals 207 units. Take note of the trigonometric ratios. In fact, SOHCAHTOA may be easier to remember. They work in right angle triangles. The clue is to identify the right angle triangle. We can use trig ratios to find missing lengths or missing angles. For example, a ladder with legs 5 meters length, 6 meters apart. If we draw this triangle, we will not be able to use the trigonometric ratios. You always have to find the triangle with a 90-degree corner. Cosine of 37 equals x over 5, so x equals 5 times cosine of 37, 4 meters. Same with this hexagonal 4 centimeter side knot. We can divide it into 12 of these right angle triangles. Tangent of 30 equals 2 over y, so y equals 2 over the tangent of 30, approximately 3.46 centimeters. Think of a boat that sails east 5 miles and north 2 miles. What bearing does the boat follow? We want to draw a triangle where the known lengths make a 90-degree angle. We can use trig ratios in reverse to find missing angles. If the tangent of z is 2 over 5, z is the inverse tangent of 2 over 5. Set out your calculator in degrees and you should get 21.8 degrees. Finding a missing angle when the right angle triangle is given is relatively easy, but can you put things together? Can you calculate bearings from written statements? A bearing is the angle clockwise from the north direction. So the bearing that the sailboat must follow to reach the lighthouse is 068, a 3-digit number. The angle of elevation of the top of a building from point P on the ground is 60 degrees. Point P is 20 meters away from the base of the building. Find the height of this building. Well, we can use the ratio opposite over adjacent. So tangent of 60 is x over 20. So x must be 34.6 meters tall. The angle of elevation of the top of a tree from a point A on the ground is 45 degrees. From a point B, 5 meters closer, the angle of elevation is 60. Calculate the height of the tree. Let's call the distance from B to the base of the tree x. We can write the equation tan of 60 equals h over x. We can also write tan of 45 equals h over 5 plus x. We have a pair of simultaneous equations. I'm going to make h the subject in both equations and equate them. That means that x times the tangent of 60 equals 5 plus x multiplied by the tangent of 45. Expanding brackets and moving the terms with x to the left, we can make x the subject. If x equals that, then the height of the tree equals x times the tangent of 60. The tree is about 11.8 meters tall. From a gondola G, the angle of elevation of the summit is 47 degrees. The gondola travels in a path inclined at 30 degrees to the horizontal. When it has gone higher up the mountain 1 kilometer from F, the angle of elevation of the summit is now 58 degrees. Calculate the height of the summit. Let's call x the horizontal distance from the foot of the summit to point G, where the gondola starts from. Let's call y the vertical distance from F to the summit. We want to figure out the height, which is y plus 1. We can divide x into two parts. To calculate z, we use the tangent ratio. Z equals 1 over tangent of 30. Z is approximately 1.73 kilometers. Now that we know z, we can write two other tangent ratios, one for the small triangle and another one for the big triangle. This is a pair of simultaneous equations. Making y the subject of the first equation and replacing it into the second one, we end up with an equation like this. We multiply both sides by x, we replace tan of 58 with 1.60 and tan of 47 with 1.07, and we solve for x, approximately 1.34. If x is 1.34, then the height of the summit is 1.34 times the tangent of 47, approximately 1.44 kilometers. AB is a flagpole standing on level ground. M is due east of B, the foot of the flagpole. N is 35 meters due south of M. The angle of elevation of the top A from M is 50 degrees and from N is 30. Calculate the length of the flagpole, AB. The clue here is to use one right angle triangle at a time. Using the triangle ABM, we can write that tangent of 50 equals AB over BM. Using the triangle ABN, we can write that tangent of 30 equals AB over BN, making AB the subject of each and equating both. We have a link between BM and BN. We also know, using Pythagoras, that BM squared plus 35 squared equals BN squared. We make BM the subject and we substitute it into Pythagoras. So now stop the video here and attempt to solve this equation. Tangent of 30 over tangent of 50 squared is 0.235. Collecting bn squares to the right hand side, we end up with 1 minus 0.235 of them. So 0.765 bn squared equals 35 squared. Bn is approximately 40 meters. The flagpole AB is 40 times the tangent of 30. So the length of the flagpole is 23.1 meters. Look at the graph of the line y equals x minus 2. It has a gradient of 2 over 2. This ratio coincides with the tangent of the angle A. Working in reverse, A is the angle whose tangent is 2 over 2. A is 45 degrees. The acute angle that y equals x minus 2 makes with the x-axis is 45. Look at the graph of the line y equals minus 2x plus 4. It has gradient minus 2, or minus 4 over 2. Working in reverse, A is the angle whose tangent is minus 4 over 2. A is negative 63.4 degrees, the acute angle that the line makes with the x-axis. The angle between the line y equals mx plus c and the x-axis is found by calculating the inverse tangent of the gradient m. Let's spice things up a little bit, shall we? Let's find the acute angle between these two lines. The orange line makes an angle of 18.4 and the blue line makes an angle of 33.7. Their absolute values, which is what we need to use really, add up to 52 degrees, which is the acute angle between the lines. There are two triangles that you need to use. They are given to you and you need to know how to extract information from them. One is the triangle with angles 30, 60 and 90. I want you to notice that the 30-degree angle has ratios given by sine of 30 equals a half and cosine of 30 equals square root of 3 over 2. The angle of 60 degrees has ratios sine of 60 equals square root of 3 over 2 and cosine of 60 equals a half. This makes sense because the side of one is opposite to 30-degree angle but adjacent to the 60-degree angle. That is why the sine and cosine are exchanged for angles that add up to 90. The second triangle you need to know how to extract ratios in surd form is the one with angles 45, 45 and 90. Sine of 45 is 1 over the square root of 2 and it is the same that cosine of 45. Mathematicians write it as the square root of 2 over 2 really. They avoid surds in the denominator. If you have access to a graphics calculator, you can use the ratio as a decimal to write it in surd form. For example, sine of 60. Your calculator returns an approximated value. And to find x in surd form, we square it. The calculator returns 0.75, which is 3/4 as a fraction. And now we find the square root manually. X is the square root of 3 over 2. We use the sine rule when we know one pair of side and opposite angle and either another side or another angle. For example, in this triangle, we know the size of angle 80 degrees and the opposite side 6. We also know a second side, 5, and we need to figure out the size of the opposite angle A. The sine rule states that the ratio between the sine of an angle and the opposite side remains constant throughout the triangle. That means that sine of A over 5 equals the sine of 80 over 6. We multiply both sides by 5 to obtain 0.82067 and A is the inverse sine of this, so A is approximately 55.1 degrees. In this second example, we are missing the length A, so I'm going to use the sine rule with lengths on top. A over the sine of 65 equals 12 over sine of 75. That way, making A the subject is easier. We multiply both sides by sine of 65, and A is 12 divided by sine of 75 and multiply by sine of 65, approximately 11.3. You are standing at point A. The angle of elevation from A to the top of the house C is 10 degrees. You walk 5 meters to point B, and the new angle of elevation is now 12 degrees. Use the sine rule to estimate the height of the house. The diagram looks like this. Angle ABC makes a straight line with 12. So ABC is 168. Since angles inside a triangle add up to 180, angle BCA must be 2 degrees. Now that we have angle and opposite side, 5 meters, we can use the sine rule. A is 5 times the sine of 10 divided by sine of 2. A is approximately 24.9 meters. Notice that 24.9 is the hypotenuse of a right angle triangle, where H is the opposite side to the angle 12 degrees. Using the sine ratio, the height is approximately 5.17 meters. You can use this technique when it's not possible to measure the horizontal distance because, for example, there is a lake or a surface that doesn't allow you to step in. Sam and Maria start sailing from the same spot, and Sam sails 6 kilometers due south, and Maria sails 8 kilometers northeast. When we know two sides and the angle between them, we use the cosine rule. For example, if we know the lengths of these two sides, 6 and 7, and the angle between them, 120 degrees, a squared equals 7 squared plus 6 squared minus 2 times 7 times 6 times cosine of 120. Taking the square root leads to 11.3 units, the length of A. The cosine rule states that the square of any side equals the sum of the squares of the other two sides minus the product of 2bc cosine A, where A is the opposite angle of the side that we want to figure out. If the angle A is 90, and since cosine of 90 is 0, this becomes A squared equals B squared plus C squared. Does it ring a bell? Yes, it is Pythagoras. The cosine rule can be rearranged to make angle A the subject. Swapping those two terms and dividing by 2bc, we end up with an expression for cosine of A. For example, angle A has a cosine given by 3 squared plus 4 squared minus 5 squared over 2 times 3 times 4. Cosine of A is 0, so A is 90 degrees. The clue here is to minus the square of the opposite side of the angle that we are trying to figure out. Remember Sam and Maria? How far apart are they now from each other? What is the bearing from Maria to Sam? Well, we can calculate the distance using cosine rule. They are 13 kilometers apart from each other. The bearing from Maria to Sam is the angle A plus 180 degrees. We use the cosine rule in reverse to calculate angle A. Make sure you minus the square of the opposite side, 8. The angle is 25.3, so the bearing from Maria to Sam is 205. In this lesson, we calculate the area of a triangle. For that, all we need is two sides and the angle between them. For example, in this triangle, we know the length of two sides, 12 and 11 centimeters, and the angle between them, 105 degrees. The area can be calculated using the formula a half of 12 times 11 times the sine of the angle 105, 63.8 centimeters squared. So what if they don't give us the angle between both sides? Well, not a problem. We can always use the sine rule to figure out the angle between them. How? Well, sine A over 12 equals sine 35 over 11. Solving for A, we obtain 38.7, and now we know that angles in a triangle add up to 180, so B must be 106.2. We substitute this angle B into the formula and we obtain 63.4, the area of our triangle. So what if they don't give us any angle at all? For example, let's say that we need to calculate the area of the triangle sides 12, 13, 15. We can figure out angle B using the cosine rule in reverse. Remember to minus the square of the opposite side, 15. B is about 73.6. We then replace this value into the formula for the area and voila, 74.8 centimeters squares. Let's try a bit of a challenge. A triangle ABC has A equals 50, AB equals 7 centimeters and BC equals 6 centimeters. Find the area of the triangle given that it is smaller than 10 square centimeters. Using the sine rule, we find angle C, then angle B, and finally the area. But wait a minute, the area is bigger than 10. What you may not realize is that there is a second angle whose sine is 0.89371, 180 minus 63.3. The angle 116.7 has the same sine. We explain this in more detail in our course, Master Trigonometric Equations and Functions Step by Step. For now, trust me on that. B is 13.3 and the area is 4.83. The triangle looks a bit more like this. We are going to find the area of this quadrilateral. Our quadrilateral can be separated into two triangles to make calculating the area easier. We need to calculate length A and angles B and C before attempting to calculate each area. Length A can be found using cosine rule, angle B can be found using sine rule, and angle C is the angle that adds up to 180, so 45.4. Now that we have two sides and the angle between them, we calculate the area of each triangle and we add them up. Stop the video here if you need to verify that the total area is 9,870 square meters to three significant figures. A boat travels 10 kilometers northwest and then 5 kilometers north. Find A, its distance from the departure point, and B, the bearing that it now has to sail to get back to it. We have a triangle with sides 5 and 10 kilometers and angle 135 degrees between them. Yes, because northwest is halfway, so 45 degrees plus 90 degrees makes for 135 degrees. Using the cosine rule, we can answer A. The distance from the departure point is 14 kilometers. Using the sine rule, we can answer B. The blue angle A follows the equation sine A over 10 equals sine 135 over 14, so A is approximately 30.3. The bearing B is 150 that the boat has to take to get back to the departure point. A hiker walks from a hostel for 5 kilometers on a bearing of 042 to her lunch stop, L. She then walks on a bearing of 135 for 5.3 kilometers until she reaches the campsite, C. What bearing does she need to take to walk from the campsite back to the hostel. Stop the video here and see whether you can answer the problem. The two parallel lines heading north make the blue angle 42 degrees. The green angle is what is left to 135. That makes the green angle 93. The red angle is 87 because it makes 180 with the green. Now that we know the red angle, we can use the cosine rule. HC is approximately 7.09 kilometers. I'm going to find the bearing using angle LHC, which is 48.3. So 42 plus 48.3 plus half a turn makes for the bearing that takes the hiker back to the hostel 270 degrees clockwise. And that wraps up our comprehensive look at geometry and trigonometry. If this helped you clear up some concepts for you or your students today, please hit the like button and subscribe. It really helps to get these resources in front of more teachers. Don't forget, you can grab all 15 PDF lessons and videos over at my website to use in your classroom tomorrow. Thanks for watching and happy learning!